Live. Cool. Okay. Wow, it's been a week that I have off work today, so I can finally stream again. Just make sure everything's correct. Oh, okay. Let's get started then. Continuing off from where we left off last time, Seance, because I believe I had to go to sleep before work the next day, which is why I stopped early. Yeah, let's remember what these things are. The rules. Cells joined by black dot contain digits in a 1:2 ratio, so crappie, black crappie. And cages joined by a green square have sums with a difference of at least 5. Digits cannot repeat in a cage. So German whispers but for cages. Not all dots or squares are necessarily given, so no negative constraints. Okay, so going off the logic from last time, just gonna refresh what I did. This is a 9-cell cage, so it has to be 45. So this cage is at most 40. I believe. Yeah. This cage over here, if this was a 40, then this cage would have to be 35 or less, or 45 or more, but it is an 8-cell cage as well. So it has to be less than 45, and it cannot be less than 35, because the digits... Why are the kids so loud? The digits adding up in here have to be 36 or more. 1 through 8 is 36. So this is 39 or less. 39, 38, 37, or 36, making this outside digit a 6, 7, 8, or 9. And then over here, that means that this over here would have to be 5 more or 5 less. It couldn't be 5 less because then this would have to be bigger. So it has to be 5 more, making it either 44, 43, 42, or 41, which is the 1, 2, 3, 4 left out there. One, 2, 3, 4, 5, 6, 7, 8. Which does mean that the cell missing out of this one is going to have to be a 6, 7, 8, or 9. Same as over here. Well, let me close my door real quick. Okay, I'm back. So why couldn't this be a 6? If this were a 6, then this would be 39. And then this over here, which has to be 5 more. Could be 5 less, because 34 is not achievable, or less. And 5 more than 39 is at least 44. And it can't be 45, so this would have to be a 1. And then this cell, maybe? Because this cage also has to be 5 less than that one. 5 or more less than that one. We do know that all these yellow cells are the same because this one in this box has to go here, can't repeat any of the cages. Therefore in that box has to go there, can't repeat in the cage, can't go there. And over here couldn't go in the cage, you can't go there, so it have to go there. So those are all the same. We know that. We know that this cage over here is 9 digits, so it has to contain one of every digit. Yellow can't go anywhere over there in the cage, so it has to go there. We also know that this one has to go in this cage somewhere. Can't go in any of those cells, so it has to go there. So that's how we know those. This cell is either pink or that cell right there. I'm not sure whether this is on a 6, so I'll just put 6 as an option there again. But this can't be a 9. A 4, I mean. Can it be a 4? If this were a 4, oh, maybe that's why. Yeah, that's why. This over here is both at least 5 away from that cage and that cage. So if this were a 6, making this cage a 39, then these 8 cell cages cannot be 34 or less. So they have to be at least 5 more, which has to be 44, can't be 45. So both of these cages have to be 44. But there's only one way of making 44, and that's every digit but 1. So this would have to be 1. But then this cage cannot add to 44 now, because it has a 1 in it. So that's why this is not a 6. Okay. This cage is missing a high digit. This cage is missing low digits. Missing a high digit. Missing low digits. So whichever of these is the one missing out of this cage has to be low, as well as one of those having to be low because of that cell. Hmm. These being 5 difference is not at all constraining. At least 5 difference. Because if this were a 1, this could be anything from 6 to more than 6. But you could have like a 2, 4, or something as high as 8, 9 being 17. Yellow in this cage goes here. Maybe there's something about this being 5 away from all of these cages, which have to be at least 5 away from each other. Hmm. This cage here has to be either 3, 6, 9, or 12. Those are all 4 possible black dot digits. 1, 2, 2, 4, 3, 6, and 4, 8. It's not 2, 4, because then it would break that cell. But it could still be 3, 9, or 12. 1, 2, 3, 6, or 4, 8. What's the lowest this could be? If this were a 2, 4, 8, well, I think it's a 2, 4, and it's... So what's the lowest I could be? 1, 3, 5, 7. Which is 16. What's... Ah, maybe that's it. The lowest this can be is 16. So, no matter how small this is, it can never be going upwards 5 or more to these. Because even if it's the lowest, which is 16, 1, 3, 5, 7, 1, 3, 5, 6 actually, which is 1, 3, 5, 6 is 11 plus 4 is 15. 15, never mind. But even if it were 15, if this were even the least, which is 5 more, it would be 20, which cannot be done in 2 cells. I need 2 Sudoku digits. So whatever this is, all these cells have to be 5 or less. If this was the lowest it could be, which is 15, then these are all 10 or less. 10 or less means that they're going to alternate parity, as in the highness or lowness of it. Except you could still have a 5 going to both. Okay, there is still sort of an alternating parity thing. It's just 1 to 5 and 6 through 9, 6 through 10. So if this were a 3, then these would have to be 8, 9, or 10. 3, 8, 9, or 10. This is also low, which would be what? If this were 3, this would have to be at least a 7. So that's not really possible, no. That one can't be a 3. If this were a 9 instead, though, 3, 6, this would have to be low. 4 or 3. There are 1, 2, that could be 4, 6. Or 4, 5 even. So that still works. What if this is a 12? If this is a 4, 8, then this has to be 17 or more. What's the max this could be? 30, 97, 6. In which case, there's so many options for what these could be. You could have 17 going to 12 going to 6. Oh, this one could be 6. Or you can have alternating parity, like 3, 7, and then 12. Huh. The lowest this can be is a 10. The highest it could be is 17 plus 6, which is 23. So this is any number between 10 and 23. Which means this can be any number between 15 and 30. Hmm. Bless me. If this were 1, 2, these are 1, 2, 4 8s. If this were in 3, 6, if this was 1, 2, or 4 8s, because it can't be 2, 4, then this has to be a 3, 6 pair. Otherwise, this is a 3, 6 pair. I guess that just means that these two just cannot be 3 and 6. I feel like I'm gonna have to do a seance and complete this puzzle. What is the break-in? This could still be a 4, with both those being a 9. Just means that 9 would be one of these cells. Huh. This is 12. This would be 1, 2, and 4. 8, 4, 12. This one cannot be 17, which is 5 more than 12. Can be more than that. Can't be 8, 9, and it can't be more than that. So it would have to be lower. It would have to be 7 or less. Even if it was as max as 7, this couldn't be 5 less than that. Could be 2 or less. So it would have to be at least 5 more. Lowest this can be is 3, so this is the lowest this can be is 8. So assuming that this is the highest cage, 12, then this is at least 17. You could just have that being a 48 makes that a 421. So then you could have a 3 there. And it's 10. It's at least 5 less than whatever this would be. I genuinely have no idea where to start with this puzzle. It's not set, is it? How would we even compare, though? Hmm. Ah, this over here. Where does it go in this cage? It's not over here. I mean, in this box. It's not in the cage over here. And if it were either of those cells, then it would have to repeat somewhere up here in the same cage as that. So this one has to be purple. Or pink, whichever one you want to say. That's something. These two cells, one of them, both of them, go here. Which means neither of them are 2 or 4. So this one over here, which is either one of the green or the purple, cannot be 2 or 4. It has to be 1 or 3. Uh-oh. None of these cells can be 2 or 4. One of them is a 1 or a 3. Huh. One, 2, 3, 4, 5, 6 is 21. What's the highest cage going to have to be? Could have 10, 10, 5 or less. Or 9, 10, and 4 or less. If these were both 1, 3, that'd be amazing. But force that to be a 9. Yeah, wait, I'm getting over this puzzle. I'll do this one later as well. Actually, I was almost done with this puzzle. So, for this one, some product lines. One digit on a line equals either the sum or the product of all other digits on the line. Of course, with this one, it was the 8 being the multiplication of all these. 2 times 2 times 2 is 8, times all the 1s is 8. For this one, it's going to be addition. 9 is equal to 2, 3, and 4. This one is also multiplication. Or addition, actually, sorry. 2 plus 2 plus 3 is 8. 2 plus 2 plus... Oh, 1 plus 2 plus 2 plus 3 is 8. And then 1 plus 2 plus 2 plus 4 is 9. This triangle can either be addition or multiplication. Same for this one, has to be addition. Either 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. But the options. This one's addition as well. 9 equals 2 plus 3 equals 4. This one is also addition. 9 is equal to either 3 plus 6 or 4 plus 5, right? What? Oh, right. Either we have a 9 here, or a 9 there. There's always a 4 here. So this is either 3 and 4 adding up to 7, or it's 9 and 4 with a 5 with 4 and 5 adding up to 9. This one's either 2 times 4 equals 8, or 2 plus 6 equals 8. This one's either 3 plus 2 equals 5, 3 times 2 equals 6, 3 times 3 equals 9, 3 plus 3 equals 6, or 3 plus 6 equals 9. This one can still be an addition or a multiplication line. Same for that one. This one is an addition line. 1 plus 2 plus 3 plus 3 equals 9. So now we figure out the next step in the puzzle. We do have a 4-6 pair here. One of these is 3, 5, or 7, which goes with 3, 5, 7, 8, 9. One of these two is an 8 though. One of those is a 2. One of those is a 6. Maybe if I added all options for these cells. If this was a multiplication line, you can't have 1 and 2 on any cell. So it has to be 3 times 3 equals 9. That makes this a 3, 4. If it were not addition, if it were an addition line instead of a multiplication line, then if this were the high digits, it couldn't be 3, couldn't be 5, that would have to be 3, that would have to be a 2, which would not work. It could be a 7 with the 3, 4 there. It could be a 9 with 3, 6, or 4, 5 in either direction. If this is a 6, that's a 4, one of those is a 3. Otherwise, if this is part of the lower digits, you could have it this way, it could be 3, 5, well it couldn't because of that 8, so it has to be 3, 6 to have 9 there, or these are the lower digits, which case it could be 3, 4 and 7, 3, 5 and 8, or 3, 6, or 4, 5 and 9. Yeah, there are way too many options there. If this is a multiplication line, it would have to have a 2 on it, because you couldn't have something as low as 3 and 4, because that'd have to multiply to 12. There's either a 2 over here with the 3 multiplying to 6, or a 4 multiplying to 8. Otherwise, it's an addition line, in which case either it adds up to 6, 7, 8, or 9. We can even have a 3, 4 here and up to 8 or 9. 3, 4, 3, 5. We've gotten pretty far with this puzzle. This is either 2, 3 a.m. to 5. Oh, that's not the case. This isn't a 5. Because either you'd have 2 plus 5 a.m. to 7, or 2 plus 3 a.m. to 5. So it'd have to be 2 plus 3 a.m. to 5. Yeah. You couldn't multiply anything to get 5, and you couldn't multiply 5 by 2 to get 10. And then if you had 3 and 5, though, then this would be 4, 9. And that'd have to be a 5 to add with 40, it's a 9. So that's not a 5, it's 6 or 7. You could still have a 3 here, with that being 6. 2 times b equals 6. Or an 8 here with 2 plus 6 equals 8. Or 9 there with 2 plus 7 equals 9. If this were a 7, that would be 3 and 4. Making that a 6 and an 8. Wow. Willed it down 1 digits. If 3 is there, then 3 is there. Yeah, I think that's it. This can't be a 3. Because if this were a 3, then you'd have 3, 4 here. Then you need another 2 to get to 9. So this is 2 and 9. But then by Sudoku, 3 is here. And then what do these do? You can't multiply these 2 to get 12, so you have to add them to get 7, which is not possible. So this leads to another 3. So what if this is a 4? What if this is a 9? 9 makes that a 4, makes that a 3. Which could either make that a 3 or a 6. What am I missing? 927, 936, 235. Eight is one of those, yes. I don't think this can be a 9. Yeah, this can't be a 9, because these don't multiply to 9, it can't be 3, 3. And they can't add, there's not 2, 7, 3, 6, or 4, 5. So at least that's not a 9. 8 could be 2 times 4. 7 could be 3 plus 4. 6, 2 times 3. Maybe 2 plus 4. Indeed, very small, very stumping. I have no idea where to look next here. What's even worse is I'm so tired. I'm almost falling asleep, honestly. But I shan't. I shall go through these puzzles. Nah. You think I take naps? That's hilarious. One of these is a 4. You should see if you can find the next step in this puzzle. Good practice. This was 5 and 7. 5 or 7. It would make that a 3. But that one can't be a 3. But it would make that a 3 and that a 4. Honestly, same. We're all washed. This breaks somehow. Does it break? Why can this not be a 3-4 pair? If this were a 3-4, this would be a 4-9. It's a 4 there, 9 there. One of these three is a 9, because one of those two is a 9. So this one can't be a 9. If this were a 9, then excuse me. Just stretching a little bit. If that were a 9, then this would either have to be 2, 7, 3, 6. Couldn't multiply to get 9. 2 3s. So this can't be a 3 anymore. If this were a 3, and that were a 3, which is what that would have to do, then these couldn't be, one of those couldn't be the highest digit. Because then it's either 3 plus 0, which is not a Stoke digit, or 3 times 1, which cannot be on that line. So these would have to both be low, which couldn't be 3 times 3 equals 9. And it couldn't be 3 plus 3 equals 6. So this is not a 3. That's not a 3. There we go. This is the next step. That's a 4-9 pair. Which makes that a 5. These are no longer 5. This is either 3, 4, or 6, 7. One of these is a 5. This is not a 5. This is not a 9. So this is not a 7. Because then you couldn't have 2 times 5, 2 plus 5 equals 7, or 2 plus 7 equals 9. Also, these are not 9s. This one is a 9. This one is a 6. It's either 2 times 3 equals 6, or 2 plus 6 equals 8. This is not a 6 either. These are not 9s. One of these is a 9, with either 3 plus 6 or 2 plus 7. That's not a 5. If it's a 9, this is 2, 7, or 3, it can't be 6. So can this be a 3? If this were a 3, yes, so that'd be 4, 7. If that were 9, it couldn't be 3, it couldn't be 6. So it'd have to be 4, 7. So does this always have to be a 7? Yes. This can't be the highest digit. Well, yes, it can. But if this were a 5, it can be the highest. It couldn't be 2 plus 3, or 1 times 5. So it'd have to add up something. It couldn't be 5 plus 2 equals 7, 5 plus 3 equals 8, and it couldn't be 5 plus 4 equals 9, so that's not possible. If this were an 8, or just, really, if this were a 9 over here, then it couldn't be 3, 6, it'd have to be 2, 7. If this were a 4, it could be 4 times 2 equals 8. Never mind, never mind. So either this is 927 or 437 are the possibilities. If this is a 3, then that's a 9, that's a 4. If that's a 3, that's a 9. That's a 2, 7, that's a 9. This is not a 4. This is either 3, 4 in this order, or it's 6, 7. If this is 3, 4, then that's a 4, 9, making that a 3. Otherwise, this is 6, 7. That's a 5, that's a 7. Am I learning? There's always a 3 here. There can't be a 2. If this was 2, 7, then this would be a 5. That would be a 7. This would be 3 and 4. And that would be 4 and 9, and there'd be 2 9s clashing. That's what I'm learning. So this has to be 6, 3. Making that a 1, 3. That's a 1 now. This is a 6. This is a 7 or 8. Down here's a 5, along with the other 7 or 8. One is a 2 with a 5, 7 or 8. Can't be a 5. One of those is a 5. This is 2, 7 or 8. 2, if this were a 2, this would either be 5 or 6, additional multiplication. If this were a 9, then this would be a 6. So this is never a 9. 9 would have to have 3 times 3, or 3 plus 6. This is 5 or 6. If this is a 3, then that's a 3. Okay. 3, 4. 3, 4, 8, 7. 6, 7, 8. But these can't have 7 in it, because if they did, that would make this a 3, 4. That a 5. 3, 4 makes that an 8 and that a 7. That 5 makes that a 7. There's 2 7s clashing. So these do not contain 7. They are 3, 5, or 9. If this were a 9, that would be 7. If this were a 5, then that would be 7. If this were a 3, that'd be 6. So this can't be a 4. Yeah, no, it can't. Because it can't be the highest digit. Neither can do. If 4 is the highest digit, then either you have 2 times 2, which does not work, because it's 2 2's, or 2 plus 2. So it's either 2 plus 4 equals 6, but there's no 6 there, or it's 2 times 4, which is 8. There's no 8 there. So this is not a 4, which means it's not a 3. This is a 6, 7 pair, making that a 5. That a 7, that an 8, that a 5. These are not 5s anymore. This is a 3 then. This is a 4. This is 7 and 8. If this were a 9, then this would have to be either 7 plus 2 or 8 plus 1, which does not work. So it is a 3. This is the highest digit. Either 7, which is 3 plus 4, which does not work, or it's 8, which is 3 plus 5, which does work. This is a 9. So this is a 7, that's a 6. This is no longer a 7. This is not a 9, so it's not a 4. This is not a 5. 6, 7, or 9. This is a 7. This is a 7 as well. Which could be 7 plus 2 equals 9, or 4 plus 3 equals 7. These are no longer 7s. I saw an 8. This is a 5, 6, 9 triple. So the rest of the digits are 4, 7, yeah, 2, 4, 7, 8. So this is a 4, 8 pair with a 2, 7 pair. That's not a 7 anymore. 4, 8 pair makes that a 3, which makes that an 8. This is a 3, 9, therefore. These are not 7s. It's a 2, 8 pair. So this is a 4, 5, 7 pair, a triple. This is not a 5. 4, 7, 9 go here. This is not a 7. This is a 4, 9 pair. We have 4, 6, 9 to go over here. This is a 7. That's not a 7. 7 is one of those 2 digits. Either 2 goes here, 3 goes here, or both of them. Oh, this is a 3, that's a 2. That's a 9, that's a 4. That's a 9, this is not a 9 anymore. So this cannot be a multiplication line, it has to be addition line. It cannot have a 2 on it. So it's either 3, 4 with an 8, or 3, 5 with a 9. Can't be 3, 5 with a 9, so it has to be 3, 4 with an 8. 8, 4, 7, 4, 7, 5. That's not 6 or 4 or 9, so it has to be 6, 9, 4, 5, 9, 6, 5. This has to be 3, 2, 5 with a 9 there. It's a 2 and a 7, 7, 6. That 8 goes here, that's an 8, that's a 4, that's a 4, 9, 5 and 6, 8, 2, 2, and 5 and 6. Nice. We actually completed it. It was just this line. I didn't think about it hard enough before. Okay, next one. Accidental Pikachu. Normal Sudoku rules apply. The line is divided into segments, as noted by black diamonds. Digits may not repeat within the segments. Adjacent segments have sums in a 1 to 2 ratio. Okay. Okay. So black dots but for line segments. Like the German Whispers but for cages before. Two, 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 1, 1, 1, 2, 2, 1, 2, 2, 2, 4, 5, 5, 2, 3, 6. Okay. Digits may not repeat within the segments. These over here are essentially just black dot digits but in a diagonal fashion. But you could have something like 1 to 2, 2 here. So what about this? Along with that. This is at least 21. You can't be multiplying upwards by 2, because then that's at least 42. In 2 digits is not possible. But if you have 22 divided by 2, then this could be 11. Or you could have 12, 13, 14, 15, 16, 17, or 18. Because the max this could be is 987,654. Which is 39. 18 times 2 is 36. So that still works. Bless me, sorry. This maybe it's more restricted along these. 15, if this were 15, this would have to be 30. 16 would make that have to be 8, which is not possible. Anything more than 15 would have to be even. So 18, 9 is not possible. 20, 10 is possible. 22, 11, 24, 12, etc. Yeah, all those work. However, this, which is at least a 10, can't multiply upwards. It has to multiply downwards, so this has to be even. 10 to 30. This can't be 30. Yeah, if this were 30, this would be 15. And then what's 15 times 2? 30 does not work in two cells. 15 times 15 divided by 2 is 7.5, which also does not work in Sudoku digits. So this is in 15. This is an even number, greater than 20. So possible options are 20, 10, 5. 5 does not work. That does not work here. 20, 10, 5, because then this 5 in order to work would have to be 1, 2, 3, and 4. 1, 2, 3, or 4. 1, 4, or 2, 3. This 10 is going to be a 1, 2, 3, 4. But this sees every single digit on this 10 line. And it has to be 1, 2, 3, or 4, but it also has to be on this line, 1, 2, 3, and 4. That does not work. 22 makes that 11, which does not work. So this has to be divisible by 4. Yeah. 24, 12, 6. Could work. Oh, also, because this is 24 or more, it can't be 20. Because this is 24 or more, this one cannot multiply upwards. You can't have 48 or more. So this has to multiply downwards. So this has to be at least 15 though. 1, 2, 3, 4, 5. So this can't be 24. Can't be 26 because that'd be 13. Can't be 28 because that'd be 14. So it has to be at least a 30. But also 30 is not divisible by 4, so it has to be at least 32. Which should make that a 16. 32 makes both those 16. 36 makes both of them what? 18? Yeah, 18. 1, 2, 3, 4, 5. Ah, but it can't be 36. Because the most it's going to be is 98765, which is 35. Thus, it has to be 32, making these 16. There we go. 16 makes this one an 8. And this one being 16 means it has to be 1, 2, 3, 4, 6. 16 can't multiply upwards, so this has to be an 8. 8 can't be a 4 here, because these cannot repeat, so this has to be 16. This can't be an 8 in 6 cells, it has to be a 32. Which makes this a 16. This can't be 64. That makes this one an 8. This one could be 4 or 16. If it were a 16, that'd be 8. 4. 2 or 8. All those work. But since this is an 8, this is either 16 or 4 as well. Oh yeah, this is 16, this is 7, 9. Eight makes out a 2, 6, or 3, 5. 32 though, 6 cells. It means that the other 3 cells are going to add up to, what, 13? Yeah, 45. So 13 is either 9 plus 4, which is 1, 3, or 7 plus 6, which could be 1, 5, or 2, 4. Thirty-two 32 and 5 cells. 35 is the max, there's 3 degrees of freedom. No options for that, so I'm not gonna think about it. This sees all of these digits, so it has to be 5, 7, 8, or 9. Options 16 or 4. Options for this 8 or 8. Yeah, it just has to be 8. Because 16 can't go to 32, it has to be down to 8. 4 can't go down to 2, it has to go up to 8. So this is always an 8. Then 8 has to go to 4 here. And then this can't be a 2, so it has to be an 8 as well. Which makes this either 16 or 4. Which means this is going to either be 2 or 8. 8 would have to go to 4 here, which it cannot. So this has to be a 2, making that a 1. Which makes that a 2. So this is a 4, which is 1, 3. This one cannot be 1, 7, cannot be 2, 6, has to be 3, 5. Making that a 3, that a 1. This one has to be a 4, so it is 1, 3. This one cannot be 3, 5, or 2, 6, has to be 1, 7. Cannot be 1, 7. Cannot be 2, 6, has to be 3, 5. This can't be 4 anymore, it has to be 16, which is 7, 9. This is not a 2. That's not a 1. If this was 7 adding up to 6, it would have to be 1, 5, it couldn't be 2, 4. And if it's 9, it has to be 1, 3, so there's always a 1 there. This 8 cannot be 1, 7. It could be 2, 6. It cannot be 3, 5, but it could be 4, 4. 2, 6, or 4, 4. This is not a 1 or a 2, it's not a 1 or 2, it's not a 1. This is not a 1 or a 3. Right, where does 1 go? Let's go there. 2 can go there or there. This is not a 4. 4 is one of those cells. This is a 1. That's a 7. This is not 1726, has to be 35 in that order. That's a 6 therefore. These are knots. 3 is one of those two. 3 now goes here, so this is a 9, that's a 7. This is a 9, this is a 6-8 pair. This needs 13 more. Can't be 8, 5, or 7, 6, has to be 9, 4. Let's add 2, then a 3, 4 pair, which is resolved. 7. That's a 2. 6 and 8. That's 6 and 8 as well. So is that. This is 4, 5, 9. That's not 4. Hmm. 4 is one of those two. 7 is one of those two. 9 is one of those two. So this is an 8. Make a signal as 1, 2, 3, 4, 5, 6, 7, 9. Let's add 8. That's 4, 9, 4, 7, 7, or 9. Boo, 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 boo. Don't need this anymore. This is already done. We have 2, 4, 5, 6, 7, 8, which is 15, 25, 32. Yeah, that works. Six is one of those three. This is 6, that's an 8 by Sudoku. Six makes that a 6 now. Makes that a 6. We have 5 and 7 to go in that column. 3, 5, 7, 9. One, 4, 7, 8. 2, 4, 6, 9. Three is one of those two. If that were a 3, then the rest line adds up to 29, which is 975. This would be a 975 pair. Could work. We make that an 8, as well as that one. 8 is one of these 4 cells. 8, 7, 6, 5, 4. Does that work? That'd be 30. No, so no. It has to have a 9 in it as well. 9 somewhere over there. 16 in 4 cells has to contain a 1 or a 2, or both. If this were 2, then 2 would not be on the line. You would need a 1 with 3 more cells, adding up to 15. Excuse me. Could be 4, 5, 6. Could be 3, 4, 8, or 3, 5, 7. Well, it couldn't be 3, 5, 7. If this were a 9, it couldn't be. There couldn't be a 9 on this line. Because you would need 1, 2, and 4 to add up to 16, which would break that cell. So those are not 9. One of those two is a 4. This is 2 and 6, making that a 4. Or that's a 4. So that's not a 4, that's not a 4, that's a 9. That's not a 9. This is a 7, that's a 4. Either 4 is on this line here, or it's not on it at all. This is not a 9. One of those two is a 9. We have 2, 8, and 9 to go in this column. This is 2, 5, 7, or 8. Can't be an 8. 8 is one of those two cells. If this were an 8, then the rest of these would have to add up to 8 as well. Which it couldn't, because there would have to be a 1 on the line. And there couldn't be 1 there, can't be 1 there, can't be 1 there. If this were a 7, it would have to add up to 9, which would have to be 2, 3, 4. 2, 3, 4 though breaks that digit right there. That cell right there. So this is a 1. 1 makes one of those two a 1, but it can't be that one because these can add up to 31. So that's a 1. That's a 1. This is 2, 4, and 8. These two were odd, and two odd digits adding together making even digits. And since 16 is the even digit in total, these two must add up to even digits. And because that's even, that must also be even. 2, 4, 6, or 8. Can't be a 4. Can't be a 6. Can't be a 4 because then both of those cells, it would see that cell and it would see that cell by the line. So it couldn't be that one. This is 2 or 8. If this were an 8, this has to add up to 8. It has to be 1, 2, 5, or 1, 3, 4. If this were a 2, then these two cells add up to 13. Is that possible? 16 minus 3 is 13, yeah? 13 is either 9, 4, 8, 5, or 7, 6, which is not possible. Okay. So this is an 8, and this is either 2, 5, or 3, 4. Making that a 6. That's not an 8. 6 goes on one of these two cells. 6 and 8 is 14, plus a 9 is 23. We need 9 more. Which could be 2, 7, or 4, 5. So either we have 2 here, with 6, 7, 9, or we have 4 here with 5, 6, 9. Either way, that 2, 4 makes that cell a 6, which makes that a 2, which makes that a 4, which makes that a 2, which makes this a 6, 7, and that a 9. That's no longer a 7. These are no longer 9s. This is 5 or 8. It's not an 8, it's 5. 8 goes there. That's not an 8. This is an 8. This is an 8. That's an 8. That's a 7. 7, 6. This is 2, 4, 5, or 7. That's not a 2. That's not a 2. That's a 4. That's a 5. That's a 3. So is that. Then we have 4 and 9 to go. Making that a 2, then a 9. That's a 5. That's a 9. 9, 9, 4. This is 5 or 7. 7, that's a 5, that's a 5, that's a 7, 7, 5. Then we have 4, 2, 2, 4. Nice. Not too bad. Next one. Asham's Welcomer. I have no idea what that means. Philomeno. Divide the grid into polyominoes so that polyominoes of the same size don't share an edge. Each cell contains a number equal to its polyomino's size. Moon or sun. Draw a non-branching, non-intersecting orthogonally connected loop to the centers of some cells. The loop visits each polyomino exactly once. Within a polyomino, the loop passes through all moons and no suns, or all suns and no moons. Every polyomino has at least one moon or sun visited by the loop. Okay. The loop may not pass through the same type of clue, sun versus moon, in two consecutively visited regions. Okay. Arrows. The next cell in the direction of an arrow is part of a polyomino containing a total of n suns and moons, where n is equal to the number in the arrow's cell. So, this is a loop and Philomeno puzzle. Philomeno, we've done many of those by MathPesto. If this were an area of size 6, then all these would be 6, and it has a moon and a sun in it. Also, every single phenomenon has a loop going through it. The loop visits every single phenomenon. And every phenomenon has a moon or a sun. Reason why is because every polyomino has at least one moon or sun visited by the loop. And because the loop visits every polyomino, then every polyomino has a moon or a sun. Okay. And then the arrows count the number of suns and moons in a polyomino. So if this were a polyomino, 1, 2, 3, 4, 5, 6, then all of these arrows be 6. Because it points to a polyomino with 6 suns and moons. Okay, let's get into it. What I realized from that is that, well, these cannot be the same number as the one that is pointing to. The reason why is that none of these have a sun or a moon in it, on these arrows. And if they did go into the cell that is pointing to, then say for example this is a 3, then it's saying that there are 3 suns or moons in this polyomino. However, that means that every single cell of that polyomino has to be a sun or a moon. But you already have one here that's not a sun or a moon. That's impossible. So we can delineate all of these. And those are all the orthogonal connections that I can delineate. That means that all of these, because the cell that they're looking at cannot escape this area, the polyomino cannot escape anywhere. It's only looking at a region that has at most 3 suns and moons. So these are all counting up to 3. But none of them can be a 1. Because otherwise it would have to have a sun or moon in it, which is not possible. That's true for all of these. None of them can be a 1. These are 2 or 3. However, if any of them are 2, then you have a phenomenon of size 2. Well, not necessarily. You have a phenomenon that has 2 suns and moons in it. But then you have to have a separate phenomenon that has only 1. But that's impossible. So all of these are 3. And none of them go here. This cannot be a 1, it has to grow. And because it's the same number as this one, it's kind of the same cell, it has to connect like this. But it's more than 3. This 3 cannot go here, because then this would be a 1, but then it would have to have a sun or moon in it. So it has to go here and ends. This has to go to there, at least. Because this is at least a 3, but it has to be more, because it can't be a 3. It has to be at least a 4. That means that this one grows to at least there. Also, this one is the same color as that one. It's kind of the same thing. This, because it has to have a sun or moon in it, has to go here. Let's just fill that in. This has to be a 4. Can't be 2, 2, because then you have two phenomenons of the same size touching each other. You can't be 3, 1, because then again you have a 3 touching somewhere over here. So it has to be a 4. Whatever will be, the future's not ours to see. Que sera, sera. This one could be part of this, or it just has to go out and touch one of those at least. This, if it doesn't go here, then those two have the same digits. I think. Wait, are they? Welcome, Isaiah. I've seen a sun and moon puzzle before, but it had a diagonal loop. I forgot who did it though. It might have been Dorlier. If this doesn't go here, then it goes to at least there. But this one cannot be a 1. It has to grow to at least one more. So it has to, this one then has to grow to go to at least there. Which means that this is the same number. If this does go here, then, well, this is at least a 3. But there are many ways you can do that over here. This is at least a 4. So is that one. At least a 4. This is at least a 5. Let's do the loop. I'll make the loop red. The loop in this region, also let's make this not black. Because the I don't like these puzzles much. Most of the time they have a path that's either really grandy or has a look ahead that's too far it's now bifurcation. Eh? I mean some puzzles have look-ahead moments, but I don't see them as bifurcation because they're pretty easy to spot, at least in my opinion. But anyway, the loop cell, because it cannot visit the same type of moon or sun in the in adjacent polyominoes, that means that this cannot be the case. This cannot be a line segment, because then you'd have two suns visited in two different uh, shapes, two different polyominoes, which means this is forced. And that means that this can't go there, so it has to go here. And now this one has to do that. Also, the loop visits each polyomino exactly once. So in order for this one to get to the sun, it has to go here. That one now can't go there, so it has to go here. And it can't go to here, because it would visit both the moon and the sun. So it has to go down here. Whoa, don't they know it's Christmas time? This one has to go to a moon next. It can't go to a sun. So it has to go to at least there. It can't cross this border because it hasn't visited a moon or sun yet. It has to go here, and that has visited a moon. If this were to visit any of these cells, it would have to visit all of them, which means it would be at least 6. Also, this sees this polyomino, whatever it is. So this has to contain at least 1 or 2 more. Wait a minute. This, because the loop must pass through every single instance of a sun or a moon in a polyomino. The loop passes through all moons and no suns, or all suns and no moons in a polyomino. This one cannot go to here, because it only goes into a polyomino once. The loop visits each polyomino exactly once. So this line is delineated. This one has to go to here. It can't go to there, so that's delineated. So is that. Has to go here now. Again, this is at least a force. This has to grow again. Can't go there, can't go there. Has to grow here. Has to grow there. Has to grow here. This is also pink now. Has to grow there. And that is also forced to be closed, because this is also pink. So this is a 4. 4 can't grow to any of those because it would have to take all of them, so it has to grow here and finish. This 4 has to contain a sun, because the last thing was a moon, and it can't get to any sun besides this one. So that's a 4. And it does that. However, that does not need to be the 4, because you could have something like that, and that'd be part of a different polyomino. We can mark all of these entrances as non-movable. Thus, this can go here, as it couldn't escape anywhere, so it has to go here and there. Which means that this is delineated, because then it would have to take that one as well, the loop. This has to grow to at least there, and it can only grow to there or there. But either way, this one has to be a 2, because it only sees 2 suns and moons in this polyomino. This one can't be a 4, in fact, though, because it has to be a 5. It's touching a 4 over here. This 2 has to grow here in order to get a sun or moon. This one's also 2, which has to grow here. These can be delineated. You can't enter through there. That's what I'm saying. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 9. Loop does not go here or here. What else? This has to grow. Also, we can get rid of these colors. This has to grow to there, because this has to be more than 1. Could grow there. If it didn't grow there, then both these would be a 2. This one is at least a 2, though. It's at most 4. 2, 3, or 4. Don't think it's Christmas time. This one can't be a 2. It could be a 3. Can't be a 4. Could be a 5 or a 6. This is 3, 5, or 6. Hmm. If this were a 5, this one could be a 1. No, it can be a 1. This one has to grow to here. Because if this were a 1, then it'd have to be taken, and it has to have 2 cells that it could go to, but it only has 1. So this one is yellow, it's V5 and 6. V5 or 6. This means that this one cannot take the moons, because if it did take the moons, and this, it would have to go in there somewhere and exit somehow, but it cannot. So it has to take the sun, which means this one is taken. And it either goes down there, or does that. This cannot possibly be a 2, because then how's it going to get a sun moon? It already has 2 digits. 3 cannot grow to get a sun or a moon, so no. So it has to be a 4, making this have to be a 6. Which means these are also 4. They can't grow here, neither can that. 4 has to take one of these cells. This 4 could grow here. If this 6 did not go up here, then it would have to do that, and then it's broken. It closes in on itself. So it has to go up there. Christmas time now. These cannot be entrances. Because then they'd have to go past the moon. Two of those just start at 4. Can't go here. Because wherever this goes, it has to enter the 4 polyomino. But this is the sun, so the 4 polyomino has to be a moon. So it has to go there. And it must do this. at least. It could do that, or it could do that. I'm not sure how we're going to differentiate that though. I'll figure out later. Therefore, this one, in order to escape, has to go here, visit a sun. These are the same digit. They have to be 3 or more. Ah. Huh? Huh. If these connected like this, if I didn't connect like this, then the min they could be is 5. Which does work. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Suns and moons. Ah, but it doesn't. Because in this, these are the same digit. They're different from that one. But if they did connect not through here, then that makes this a max count of 5. Because there are 5 suns and moons here. But that means that these are also part of, this is also part of that polyomino. And now how is this 2 going to escape without going into the same polyomino? It can't go through there, it has to go both into this and complete itself. So this one has to go to at least there. Which means this one is a 3 or a 4. It can't go here, because then it'd be a 4 connecting to that one. Also, there has to be 2 polyominoes here. Oh, this one also can't go here. Because then it'd be a 4, and then this one couldn't have more than 3. Hmm.
That was a giant creepball explosion.
Really? How giant?
So giant.
So giant? Was it a creeper farm?
Yeah, and I dodged all of the attacks with just one shield.
Wow, good job.
And I also killed some.
You killed some.
Because AC was just kept spawning them with a command block.
I
And
see.
I was like taking no damage.
Good job.
Even if I got hit.
Close the door. Thank you, bye.
Bye 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 bye.
Okay, where was I? Wherever this goes, it has to be two different polyominoes here. Yeah, so if this were a 4, then all of these would be part of the same polyomino, making that also part of the same polyomino. And then this thing has to go to the same polyomino wherever it exits, closing itself, which you cannot do because there's only one loop in this puzzle. So this is a 3. And we can get rid of that. 1, 2, 3, 4, 5, 6, 7. You could have 1, 6, 2, 5, 3, 4. You couldn't have 3, 4. 3, 4 would be that, which would touch itself over here. So either you have 1, 6, or 2, 5. These could not be 2s, so that'd have to be a 2. With all those being 5. Which have to connect like that, so that would be 2, that'd be 5. Or 1, 6. These cannot be 1s, because there has to be 2 over here to exits. So one of those is a 1. Can't be that one. This 5 or 6 has 3. If it were a 5, it would only have 2. So it has to be a 6. With a 1 somewhere there. It cannot go, the loop cannot go to this cell. This is a 1, 6 pair. This cannot go there. This cannot be a 1, has to go to at least there. This has to be taken, but it can't go here, and it can't go there, so it has to do that. Making this a 6. Oh no. Okay, I see, okay, I see. That does not have to be taken. But the 1, how's it X? Oh, okay. That's what's happening. This is not the case. Is it? This has to exit into 2 things that are sums. So one of them has to be. the 1. But then where does the 1 exit to? It has to exit to someplace that's a moon. And it can't do it to the 6. Oh no. Oh, also this is broken. I do not speak Russian. Is that Russian? Oh boy, I did something around here that was wrong. Okay, so this is true. This is true. So is that, so is that, so is that, and so is that. That has to go there. This cannot go there. Has to go there. Has to go there as well. Because that's the sun. It has to go to a moon next. This, because it does not go there, cannot go take any of the moons. So it has to go there, has to go there, there. Because this is at least a 4. Has to end there. Making this a 4, that a 4 as well. And so are those 2. Why did it say that it couldn't go here? Because then I have to take all these cells. It couldn't go there and stop there. Otherwise, this would have to go to another sun. Couldn't go there, stop there. Because then how is it going to go to a region with the moon? This is a different region from that one. But it has to go into this region. Yeah, so this one has to go here. That's correct. It goes through each polyomino once and only once. And the loop may not pass through the same type of clue in 2 consecutive regions. Yeah. Also, give me a second. General Salam alaikum? I have no idea. Well, thank you for the first time chat, Russian chatter. I have no idea what you said though. Yeah, so this has to go here, has to go there. Also has to go there. And has to exit, can't go there, has to exit there. Which then has to do that. This one could go there. Sorry, that's what I did wrong. These don't have to be the same. This could go to there. This can't be a 1. Also can't be a 2. It has to be at least 3, so it has to go to at least there. Which means this one has to go there. It has to go there as well. This one isn't just a 4, so it has to grow here. This is forced. These two are at least 3, at most 4. Shine, shine on harvest moon of the sky. Na, 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 na. Shine on harvest moon above the sky. This cannot go here. It would have to. The thing would have to go there. So this one has to grow to at least there. This one is different from that one. This one can't be a 4, has to go to these stairs, so it has to be a 5. Which means that both of these are a 2. Have to go there. Finish. This is either a 1, a 5, or a 6. Oh, this can't be a 1 though. As then this would have to be a 1. So it is 5 or 6, so it does go to this. And this one is a 3 or a 4 as well. This could be a 5 or a 6. This one cannot be a 3 because it couldn't get a sun or moon otherwise. So it is a 4, which means this one has to go there, making this a 6. Oh, that's why, because I put this thing there. Yeah, that's why. So this one finishes there. This one has to go here. These are now all 4. This is delineated, oopsie daisy. And now this one has to do this and that. This one has to get to the sun before it leaves this polyomino, so it has to go there. Also, that is delineated. This cannot go here. Otherwise, it would have to go to a moon again. So it has to go here. And it has to visit the sun. So could go there. But it has to visit that one. So this is 4. This one can't go there. Shine on the horizon, the sky. Na, 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 June, July. This one now can't go there or there. Has to do that. Thus, this one cannot go here. So these are the same number at least. This has to visit a sun, which it has to be there, but it could get there in any number of ways. Although it couldn't do this. So it has to do that, okay. Yeah. This has to grow at least one more. It's at least a 3, but these ones can't be 1. It has to be at least 2. They couldn't be a 2, because then they both have to do that. So they're at least a 3, which means there are 3 or more suns and moons. So there has to be 2, at least 2 more. But it cannot go here, because it cannot take another sun or moon. It cannot take another sun. It has to go there. Cannot do that. No, I can't do that. It has to go there. Can't do that. One, two, three, four, 5. This has to go somewhere, has to go here. That means that's also a 4. it's at least 3. Could be 4. Could be more. If it went like there. I very much doubt it could do that though. This one goes here. This could be a 1. This can't go there or there. It has to go down here, which means that this does not go there. This one now has to do that. It can't go here because it had to be part of a circle. The sun has to go there, deleting that. So this is a 5 region, making this is that correct? Oh wait, no, yeah, that's correct. These are 3 now. But this cannot go here, because then you'd have a circle going to a circle, a sun going to a sun. So those are delineated. This 3 has to go to at least there. It cannot go here, there's no sun or moon. This one cannot iso through there, there's no sun, so it has to go there. Let's go here, unless this is a yellow digits. Unless this is a 3. No, not even them. Because if that were a 3, then this one has to go to a moon next. If that were a 3, then it can't go down there. It has to go to a moon next. So it always goes here, then there, then there. That's blue, let's call it. Which does not go there. This has to be at least a 2, so this one has to go to there. Meaning that this does not go there, so it has to go there. Which means it has to go here. So that is a 3. That's the Peter Pan dance. This is not a 2, because then that would be a 1. This one cannot be a 1. Has to go to there. Because if it were a 1, where would it go? Couldn't go up there, couldn't go there, would have to do that. But then it goes back into this thing, which is already done. So that is the same as that one. Can't be a 3. Has to be at least a 4. This one cannot go here. Has to go to there. This is a red as well. This one has to go here. Has to go here, the loop. This one has to go here and take one of those 2 cells. So those are the 3s. And that one is not. I very much doubt that this could go down here and find another. If it doesn't take this sun cell, where does it find it? At least there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has to this polyomino would then have to contain 9 9 or more really, but at least 9 sun and moons. These red cells cannot be part of it. So 1, 2, 3, 4, 5. 6, 7. It's just not possible. 1, 2, 3, 4, 5. It's not possible. Might be, but it's way too hard and way too improbable. So let's find something else. Sides went just like those crabs do. 3 steps up, because this is at least a 4. Has to go to there. So this has to go there. So 3, it finishes. That has to go there. This could connect to there. However, if this went here, it has to be more than this. This is at least a 4. And this is at least a 9. Yeah. So how could this contain 9 or more suns or moons? It can't connect to that one. Can't connect to that one. Can't connect to these, because then 9 or more suns or moons make this even more than 9. Makes it at least 10. At least, well, 11 actually. Which means this one has to be 11 sun or moons, which is at least more than 9. So yeah, this compounding effect won't work. So that has to go here. And ends. Also, this is the same. This is red. This is 1, 2, 3, 4, 5, 6. This is a 4, so is that. This, in order to get a sun or moon, has to either go there, there, or there. It can't go here, because then that would be 1, which it cannot be. In fact, what is this? This has to be at least 3 in order to get to like there or there. If it went to here and it was a 5, that breaks, I think. 1, 2, 3, 4, 6, 1, 2, 3, 4, 5. I guess that could work. Yeah, that could work. Oh, I can't go here, actually. Because that 4 ends in one of those places. It could go here. Wouldn't be a 5, though, because this is 5. Maybe at least a 6. If it doesn't, though, it can go down here, being a 3. And that could do that. Uh, hold your breath. Jump to the left. I have D&D to get to, so I'm gonna end it here. Halfway through this puzzle. Not too bad. We shall finish it later. Thank you everyone for coming, and I'll... when do I next not have work? Indeed, quite good progress indeed. I'll continue streaming on Wednesday. Or Monday, yeah. I don't have work on Monday. So Monday as well, I'll continue streaming. Alright, well, thank you everyone for coming, and good night.